All right, hi guys, this is Mr. Brink. This is topic 46, which is the next one after we left off. Hopefully you guys already have this packet with you at home and the assignment for it. If not, I'll be um, attaching it to an email that says this video is up. So hopefully you have access to be able to print stuff at home too. So remember, you guys have topics 45, 46, and 47. We're going to have to continue on with other topics after that, but I'll attach those and hopefully you have a way of printing them at home or somehow accessing them at home. If not, just do the best you can. Write down stuff on blank piece of paper from your, just on blank piece of paper on your notes as we go through this, and we'll try and get through this the best we can. So this is your third integration technique that you learn in this class. Remember, the first one was U substitution. You should always try that one first. Second one we learned in topic 45, which is integration by parts. That's when you have two variable terms that are multiplied together. So for instance, something like x squared times cosine x, that would be integration by parts, and you use the formula uv minus integral of v du. And then topic 46 is called integration by partial fractions. So obviously you're looking for something that's a fraction. Excuse me. That's not the only thing that you can do with fractions though. So remember, there's some other stuff that we'll review at the end as far as fractions go. All right, so when U substitution doesn't work or integration by parts doesn't work, these are probably expect one of these in multiple choice sections. So there's two things they can give you. One is when you have a fraction that's where the denominator is not already factored, or if they're really nice to you, then they'll give you a factored form as well. So that's what you're looking for. This is something that you guys should have done in pre-calculus as far as doing this particular process. So this may look somewhat familiar from pre-cal. The nice thing about the AP exam is they only give you linear factors. So for instance, this will just be x plus or minus some number. It won't be like x squared plus 5, which would be a quadratic factor. So they only do linear factors for this one. So these two are identical. They've already, I've already factored the bottom for you. But if it's not factored, then you want to look to see if you can factor it first. If it's not factorable on the bottom, then it's going to be another problem like completing the square or something like that that we've already seen as far as this goes. So let me pull up my pen here. All right, so this one's already factored first. There should be a dx here at the end, obviously. And then what you're going to do is you're going to take the first factor and just write an a over that. So it's going to be a over x plus 5. And then plus for the next one, we'll put b over x minus 2. Okay, that's going to be equal to this whole thing. So that's kind of our setup. Now we're going to do this little trick and we're going to crisscross these two things. So I'm going to take those two things and put it together. So it's going to be a times x minus 2. And then plus, then I'm going to crisscross these and then do b times x plus 5. And that's just going to equal the top. Oops, sorry about that. That's just going to equal the top, which is 8x plus 82 in this case. Okay, so that's always going to be my setup, is take one factor and crisscross it with the other. Now, it doesn't matter which one you put a on top of or b on top of. All that matters is that you're consistent, and then once we find a, that you put that a back over, in this case, the x plus 5, and you put the b over the x minus 2. But other than that, it doesn't matter. All right, so now that I have it set up, I'm going to let x equal, sorry about that, I don't know why that keeps popping up. I'm going to let x equal 2. The reason I do that is when I do 2 minus 2, that's going to be 0. And since 0 times anything is 0, this term is just going to go away. So I'm going to let x equal 2, which makes this first term go away. When I let x equal 2 here, I get 2 plus 5, which is 7. So that'll give me 7 times b, or 7b, equals, plug in 2 here, and I get 8 times 2 is 16, plus 9, or 82 gives me 98. And then you divide by 7, and you get b is equal to 14. All right, so now I found my b term. Now I'm going to do the same thing, except I'm going to let x equal negative 5 in this case. That way this term goes away. So if I plug in negative 5 over here, negative 5 minus 2 gives you negative 7a. Again, negative 5 plus 5 is 0, so this term goes away. Plug in x is negative 5 here. You get 8 times negative 5 is negative 40, plus 82 gives you 42, and then you divide by negative 7, and you get a is negative 6. So now I found the values for a and b. All right, now we're going to scroll down a little bit so you can see some more of the notes. And now I'm going to complete this. So again, I'm going to put this a is negative 6 over the x plus 5. And actually what I'm going to do is I'm going to factor it out because I'm going to want it out front anyway. So I'm going to put the negative 6 in front of my integral. And then that just gives me the integral of 1 over x plus 5. And then I'm going to pull out the b value of 14, which goes over the x minus 2, so plus 14, and then the integral of 1 over x minus 2, and then these will both have a dx at the end. All right, now I've broken this thing apart into two separate things that I can integrate separately. So we have to, because it's not just 1 over x, we got to consider u substitution. So we make u equal to x plus 5. The derivative du is just 1 dx, so it matches perfectly. So it becomes 1 over u, and the integral of 1 over u is ln absolute value of u, and then I replace u back with x plus 5. So I at least have to consider u substitution, but in both of these cases, it's going to work out just fine, because if I make u equal to x minus 2, the derivative is just dx, so again, it matches. What you have to watch out for is when it's not just x plus a number or x minus a number. So for instance, if it was 2x plus 5, then I'd make u equal to 2x plus 5, and the derivative would be 2x. So I'd have to put a 2 there and a half out front to cancel it. So at least think about u substitution when you're doing these. And then again, in this case, they're pretty simple. And that just becomes 14 ln absolute value of x plus 2. And then you tack a plus c on the end since there's no limits on my integral. Okay. So these are the steps that are in your notes. Factor the denominator if it's not already factored. For each linear factor, and that's the only thing they ask about on the AP exam, write as a sum of two fractions with constants a and b. If there was 3 of them, you do a, b, c, but I don't think they're going to do that to you on the test. Multiply everything by one of the linear factors and makes x equal to something so that you end up with 0, and then that lets you solve for a. And then you do the same thing for b, and let that solve for 0 as well. And then you have your A and B. Sorry about that. I'm just getting used to using this pen again that I haven't used in a while. So go ahead and scroll down there, and then you integrate the new expression just like I did, and that's your answer. So on the back, I got a couple more examples for you to do. Obviously, in this one, it's not factored for you, so you need to be able to factor this first, and there should be a dx there already written. All right, so in this case, it becomes integral of 1 over, and then the two numbers that multiply to 6 and add up to negative 5 are negative 2 and negative 3, so that factors to x minus 2, x minus 3. And now I can break it apart. So I'm going to do a over x minus 2, and then plus b over x minus 3, and that's going to be equal to, and really just need to worry about the top one. In this case, it's just 1, so you don't even have to plug in an x there. All right, then you crisscross them. It's not cross multiplying, but it's kind of like it. Basically, you're getting a common denominator, and then just ignore the denominator. So it's a times x minus 3, and then that should be a plus sign, and then b times x minus 2, and in this case, that equals 1. And again, we're just forgetting about the denominator and just working with the top. Now we need one of them to cancel, so I'm going to let x equal 3. That way 3 minus 3 gives you 0, and this one goes away. When I plug in 3 here, I get 3 minus 2 is 1 times b is b, so I just get b is equal to 1. And that's my answer for b right away. And then I'm going to let x equal, and you can probably look ahead and see that x is going to be equal to 2 in this case. So if I plug in here 2 for x, 2 minus 3 is negative 1, so that'll give me negative a. 2 minus 2 is 0, so that goes away. And again, this is just a constant 1, which tells you a is equal to negative 1. And then I make sure I take that a is equal to negative 1, and I plug it back in up here for this a. So that gives me the integral of negative 1 over x minus 2. and then plus the integral of b, which is positive 1 over x minus 3. And again, they'll have a dx on the end of both of these as well. Now this negative I can pull out front since I just want a 1 there and make that positive. Again, I'll guys have to at least think about u substitution, but if I make u equal to x minus 2, then the derivative is just dx. So that gives you the integral of 1 over u, which is ln, so it's negative ln absolute value of x minus 2. And then plus, again, u substitution, everything matches perfectly, so it becomes 1 over u, which is ln absolute value of x minus 3 in this case, and then 1 plus c at the end. Okay. Now, one thing you do have to watch out for is if they condense it down to 1 ln, then you got to do that using log rules. So in this case, I'm going to show you what that's going to look like. So it's going to be ln, okay. And remember, minus becomes divide, and plus becomes times. So actually, they'll probably write it like this. ln absolute value of x minus 3, they would write first, because it doesn't matter if I write this one first or this one first since it's added. And then the minus sign becomes divide, and then that would be absolute value of x minus 2, and they would just tack plus c on the end, and your answer multiple choice might look like that as well. Sometimes they do that, sometimes they don't. The one below, that's an example of one that they don't. So, and I apologize if you see that box keep popping up. I don't know why it's doing that. All right, I'm going to scroll down to this last one. This is an example from a previous multiple choice question on a AP exam. So the nice thing about this one is they already factored it for you, which is always nice when they do that. So I'm just going to separate it out. I'm just going to write them in order. So I'm going to have a over x plus 2 first, and then plus b over x plus 1. And again, I'm going to make that equal to the top, which is 2x, and then we're just going to ignore the denominator. So I'm going to do this little trick of crisscrossing these. So I get a, and then x plus 1, plus b, x plus 2 is equal to 2x. And then remember, we're going to let x equal something. I'll give you a second to think about that. For the first one, if I want to get rid of it, I make x equal to negative 1. And then that way, when I plug it in, that's 0, and 0 times anything is 0. When I plug in negative 1 here, negative 1 plus 2 gives you just 1b or b. This one does have an x, so I got to plug in x is negative 1 here, and that gives you b as negative 2, which is part of my answer right away. And then I'm going to let x equal the other thing that'll make this other one disappear, which is negative 2. And again, negative 2 plus 1 is negative 1 times a is negative a. Plug in negative 2 over here, and 2 times negative 2 gives you negative 4. So that tells you that a is equal to positive 4. And now I just need to make sure I put the 4 on top of the one that I called a, which was the x plus 2. So I get integral of 4 over x plus 2 dx. And then since b is negative 2, it'll be minus, and I'll go ahead and pull the 2 out front here and just do the integral of 1 over x plus 1 dx. Okay. And I showed it to you both ways because now I can take this 4 and move it out front. That way this just becomes a 1 here. Again, I got to think about u substitution, but if I make u equal to x plus 2, the derivative is just dx. Same thing over here. Everything matches perfectly. So it's just 4, and then 1 over u becomes ln absolute value of u, which is x plus 2 over here. And then minus 2, integral of ln, or integral of 1 over u is ln absolute value of u, which over here is x plus 1 plus c. And you can see here by the answer choices, they did not condense it down. So looking at that, that matches this one. So D is going to be my answer. Okay. So again, this technique is fairly easy. Most of my students do pretty well at this. The biggest thing to worry about is it's not for every single fraction. So if you have an integral of a fraction, probably the first thing you should think is u substitution. If it's already factored for you on the bottom, that's a good hint that it's probably one of these integration by partial fraction problems. But there's some other stuff you can do, like for instance, let me see if I can go down and get a blank piece of paper here to work with. All right, so hopefully you can see that well. So for instance, if I had the integral of x plus 2, and then this was, say, x squared plus 4x plus 8 dx. Okay. In this case, there's nothing that multiplies to 8 and adds up to 4, so this would not be factorable. So this is not a integration by partial fractions like this assignment's about. But u substitution would work on this one, because if I make u equal to x squared plus 4x plus 8, then the derivative would be 2x plus 4. So to get it to match, I would just have to put a 2 here, because if I distribute that, I get 2x plus 4, and if you put a 2 there, you get a half out front. Again, all of this would disappear and become your du. So it would be 1/2 integral of 1 over u, and then du at the end, and then that would just be ln. And then another thing that you might have to, or might show up on the AP exam for fractions, is if I have, a bunch of terms, 3x squared plus 4x plus 1 all over x dx. Okay. U substitution doesn't work, but remember, when there's one term on the bottom, you take each term on top and divide it by what's on bottom. So 3x squared divided by x would be 3x. 4x divided by x would be 4. This one wanted to leave 1 over x dx. And then we'd integrate them separately. So the integral would be 3x squared over 2. Integral of 4 is 4x. Integral of 1 over x is ln absolute value of x. Sorry about that. Plus c. Okay. And then another thing that we can do, again, is if we have two terms on bottom that you might see on your test, let me go and scroll down a second here. That might show up as a fraction as well. Would be the integral of, say, 2x plus 3 on the bottom. Okay, I'm going to have to fix that before the next video. Turn my pad, see if that helps. So if I had 2x plus 3 on the bottom, and I had x squared plus 5x plus 6, say, dx. Well, that didn't work either. If I had a setup like that, again, it's not integration by partial fractions. This would be long division, where you take the... All right, this isn't working at all for me, obviously. And if you're laughing at me at home because this thing keeps coming up, I totally understand. I don't know why it keeps doing that either. All right, so in that case, you'd have to multiply it out with long division. All right, as far as your assignment goes, let's go ahead and get rid of that. I think I can pull that up really quick maybe for you. All right, so there's your assignment. Most of these are pretty simple. So what I recommend you do is kind of go through them. Obviously, the ones on the front, the bottom's not factored. So you'll need to factor those first. So that's a good review of factoring. And then on the back, there's a couple multiple choice questions. One of them's not factored and one of them is factored for you. And you'll notice the answer choices have just one ln, so they do condense those down to just one ln. Okay. So that's going to be your first assignment. I'd like you guys to try and get that one done. Let's see, today's Saturday morning, so probably by Sunday to have that one done. So I'll try and post another one and try and get that stupid pop-up to stop popping up for the next one. For the most part, this is usually a pretty easy assignment. The hardest thing about it, again, is recognizing that, hey, this is an integration by partial fractions technique. The ones on here are pretty simple. In the next video or sometime I'll review some as well. that are a little bit harder, but for the most part, because they're only linear factors, they don't get super, super hard. So what I want you to do is complete this assignment. If you can take a picture of it and email it to me, or if you have a scanner at home and scan it and email it to me, just so I can make sure that you guys are doing it correct and that we're all on the same page as far as how to do these. Again, these are not going to be for grades because Birdville doesn't want us to give grades during the shutdown period. So just worry about learning the material. All right, we'll see you later.